All right, of the two methods, the first one is to treat it like it's a complex fraction. Okay, so the first thing, if you choose to treat this as a complex fraction, what you need to do is you need to rewrite it so that it's in the form of a complex fraction within a fraction. So that means any negative powers that you see, you need to move the factors to the denominator and rewrite it as a fraction. In this step, or the first step for whichever method you choose, I would always convert any radicals into rational powers as well. But if I were to rewrite this whole given expression in complex fraction form, my x plus 4 to the 1/2 is going to stay just as it is. It's over 1. In my next set, my 2x doesn't have any negative powers in it, so that's going to be in the numerator of a fraction. But my x plus 4 does have a negative power, so that whole thing is going to be moved into the denominator of that individual fraction. When you move it into the denominator, it becomes a negative. You change the sign of its power. Notice this x plus 4 didn't move into the denominator of the whole fraction. Remember, this is this power of minus 1/2 simply moves it into the denominator of that individual fraction, not the entire complex fraction. And then the x plus 4 over 1, think of that in the denominator. Okay, so again, you don't necessarily need to write these over 1s, but I do that anyway to just demonstrate what the fractions look like. So it's not a bad idea to do that in this first step of translating it into a complex fraction form. And now you can use any method. Rewrite the numerator as a single fraction, invert and multiply, or you can use LCD method. Again, I'm going to just work with the individual fractions here because that's what most students prefer historically. Okay, so looking at this, if I want to combine this whole thing into one single fraction, my LCD has to have a factor of 1. It also has to have a factor of x plus 4 to the 1/2. So there's my LCD for the numerator. So if I take the numerator of my first fraction, which is x plus 4 to the 1/2, and I multiply that by the LCD factor that's missing from this denominator. Well, it's missing the x plus 4 to the 1/2. So what happens when you take x plus 4 to the 1/2 times x plus 4 to the 1/2? Not 1/4. What are you going to do with their powers? When you multiply exponents with the same base, you do add them, which winds up canceling. So that's what you're thinking of as canceling. You're going to add 1/2 and 1/2. What does that add up to? 2 halves or 1, and anything to the power of 1 is just that value itself, right? So this first term becomes an x plus 4 to the first, minus the next fraction's numerator, negative 2x, times what LCD factor is missing from its denominator? It's not missing anything, right? So you can either leave it alone or just multiply it by 1. You don't even need to represent that. Okay, so if I simplify my numerator completely by combining like terms, x plus 4 minus 2x, I get a negative x net and a plus 4, and then the x plus 4 to the 1/2 in the denominator. Okay, now my denominator is already written as a single fraction, so I don't even need to make any adjustments to it. All I need to do is, instead of divide, I'm going to convert this into multiplying by the reciprocal. So the x plus 4 moves to the denominator, the 1 to the numerator. And so when I simplify it completely, negative x plus 4 times 1. And then here I have this common base being multiplied across the denominator, x plus 4 to the 1/2 times x plus 4. When you multiply exponents with the same base, what do you do with their powers? Add them. So 1/2 plus 1 gives you 3/2. So this would be your simplified form. If you wanted, you could remove a factor of negative 1 from that. This is an acceptable form as well. Okay, there were no canceled factors from the denominator. There's no domain restrictions that are not apparent in the simplified form, so you're good on this.